1.6 is on equations of circles. All right, so there's a standard equation for every single circle. So if I wanted to draw a circle on a coordinate plane, like an xy axis, basically there's an equation that looks like this. X minus h squared plus y minus k squared equals r squared. So I could go into a lot of detail on where this comes from. It comes from the distance formula and the fact that r is a common distance, but I'm not going to do that. I'm just going to tell you this formula is this. Can we know this formula? Think you can know this? Maybe I'll give it to you if I'm nice, but. All right, so number 1, it says graph each circle using its equation. So when we have this equation, x minus h squared plus y minus k squared equals r squared, we got lots of variables. Okay, the hk thing is our center. So our center is h comma k, and our radius, what do you think radius is? R. Surprise, surprise, right? Okay, so it says graph each circle using its equation. So in this equation, do you see how it's really like x minus 0 squared plus y minus 0 squared equals 16? What's 16? It's something squared, isn't it? 4 squared. Can you identify what h, k, and r are? H is 0, k is 0. What's r? 4. Okay, so our center is what point? 0, comma 0. And our radius is 4. So as we sketch this out, we start out at 0, 0. And I'm going to go to the right, 1, 2, 3, 4. I'm going to go up, 1, 2, 3, 4. I'm going to go left, 1, 2, 3, 4. And down, 1, 2, 3, 4. And I get a point. Now there's an infinite number of points that are a distance of 4 from that. I mean, there's some that are like over here, right? So once we get that, we draw the circle in. Have I told you the story about my professor that would always be like, here we go, here we go, here we go? Have I told you that story? No. I had this professor in college. His name was Dr. Stegemuller. He was awesome. He was really tall and skinny. He was probably like 6'5". I don't know, like maybe 150 pounds. He was really skinny. And he was super old. So like, should have retired a while ago. I'll say 75. Oh no, totally Jacob Sager, yeah. And he was a runner, so he's a man after my, I like runners. But he would do this weird thing where he would run to class, so we'd be all sweaty when he got to class, and he'd be wearing his running shorts, and then he would, like, stretch. So imagine a 75-year-old man putting his leg up here and, like, stretching while he's teaching. It was a little disturbing. But he was a champion circle drawer. I didn't know you could do this. There's competitions where you can draw circles. And so he would go up to the board. I can't do it on this little machine, so YouTube viewers, if they're watching, they're missing out on this. But he would put his hand in the middle of the board, and he'd be like, okay, this is going to be the center of my circle. And he had this, like, little southern accent, because I went to school down in Evansville. So he'd always be like, all right, here we go, here we go, here we go. And then he would go, shoo! And he'd make that sound, and oh, that's pretty good. Steggy would be so proud. But he would do the circle, and it would be perfect every single time. And I have been teaching for many years now. I think this is like my 13th or 14th year. And I still can't do it. So, whatever. All right, what do you think for the center for this one? We'll have a circle drawing competition as we listen to our quadratic formula song in a little bit. All right, so what's our center? Oh, close. Now, Wyatt said 0, -4, but look at our equation. Yeah, our equation has x minus h, y minus k. So our k is actually +4. So it's always like the opposite sign there. And what's our r? Oh, no, because this is r squared. So it's r squared is 2 squared, right? So we're going to go over to 0, 4, 1, 2, 3, or up to 0, 4, I guess. And we're going to go off of that 2 units in each direction. So I'm going to go right 2, up 2, left 2, and down 2. And I'm going to draw a little circle there. And that's our circle. Up 2, right 2, left 2, down 2. Because the radius is 2. So as long as you get those 4 guiding points, you're good. All right, so how about this one? Center and radius. Ah, he's got it. -1, 3. Perfect. And then the radius? 1. Perfect. So I go -1, 1, 2, 3. And then from that, I'm going to go up 1, left 1, down 1, right 1. It's going to be really tiny. little bitty circle there. It doesn't cross that axis, it stays right there. All right, makes sense? All right, now can you go the other way? Can you say, well, I have the radius is 9, and then I have h is -2, and I have k is 7. So can we put it into the equation? It's going to be x minus a -2. Minus a -2. And then I'm going to have y minus 7 squared equals 9 squared. So some of you guys will need to write out this initial step. Some of you guys can just jump to the final equation. What's our final equation? It's
x plus 2 squared plus y minus 7 squared equals 81.
Perfect. You got it? Does it make sense, everybody? Because the sign inside the equation was the opposite of what we had. So if I had -2, 7, I'm going to have +2, -7, because it's minus h minus k. All right, and then you might have some weird ones like this. So it says the center is 4, -3. So I know my h is 4 and my k, oops, not r, my k is -3. Okay, so do you guys remember when we did equations of lines?
Yeah.
And do you remember when we didn't have the b value and we temporarily plugged in for x and y to find b? This is how this question is. So it starts out, it has the x minus 4 squared, and it has plus y minus a -3, so plus 3 squared, equals, but we don't know r, so we write an r squared in. So we're going to temporarily plug in a point that's on the edge of the circle. Well, there's an infinite number of points that are on the edge of the circle, just like there's an infinite number of points that would be on a line. But we can plug it in to get our missing value. Okay, so we're going to plug it in to get what r is. So let's plug in 2 and 1 for x and y. So I'm going to have 2 minus 4. And I'm going to have 1 plus 3. And that will allow me to solve for y. Yeah, did you get it?
It would be x minus 4 squared plus y plus 3 squared equals 36.
Ah, so he thinks the radius is 6. Did you guys get 6? Let's see. So 2 minus 4 is -2 squared, which is 4, plus, this is going to be 4 squared, which is, so not quite. So it's going to be 4 plus 16, which is 20. Now, I don't need to find what r is, because in the equation I have r squared anyway, right? So I would just go from here now and do x minus 4 squared plus y plus 3 squared equals, and I would leave it as r squared. So I would just put 20 in. Does that make sense? So you don't need to find r. So because r squared is here, right? R squared's there anyway. So you might as well leave it as r squared. But you could write it as 2 root 5 if you wanted to. Okay, does it make sense? Do you have one more? Yeah. Any point that is on the edge of the circle. So I told you that this was on that edge of the circle. Yeah, so then you can plug in any point that's on the edge. All right, so the equation x minus 13 squared plus y minus 6 squared equals 9. Decide if the following are inside, outside, or on the circle. So if we plug in a point, and let's say our circle looks like this, and I plug in a point and its radius isn't that big, then it's inside the circle, right? But if I plug in a point and its radius is the same as on the edge of the circle, like the radius is still 3, then it's on the circle. But if I plug in a point and I get a radius of like 4, then it's outside of the circle. So I'm not going to worry about the equals 9 part right now. I'm just going to plug into the x minus 13 squared plus y minus 6 squared to figure out what its r value is. Does that make sense? Do you guys see what I'm saying? So I'm going to plug in 5. So I have 5 minus 13 squared plus 6 minus 6 squared. And I'm going to see what that gives me. So when I do that, I get 5 minus 13 is -8. So when I square it, I get 64 plus 0, so I get 64. What r value would this be then? 8. That's too big, right? We have an r value of 3 in our problem. So is it inside the circle or outside the circle? It's outside. It's too big, right? So this is outside. So same thing for these. So if I do 14 minus 13 squared plus 8 minus 6 squared, I get 1 plus 2 squared is 4. I get 5. That's r equals the square root of 5. Is that inside or outside? Inside, because square root of 5 is smaller than 3. So inside. And then I'm guessing the last one is probably on the circle, right? That's what we math teachers do. But let's check, because sometimes I do trick you, or I make a mistake. So 7 squared is 49. 3 squared is 9. Oh, maybe I did trick you. So I get 58. Well, that means our R value is the square root of 58. Oh, I don't know what the square root of 58 is, but I do know that it's bigger than 3. It's around 7.6 something. So this one's actually outside as well. All right, does that make sense? All right, was that the last thing? I think that was the last thing. Yep. All right.